5-2. Thought it'd be fun. It's probably not gonna be. This is properties of exponents, and I don't know what's supposed to be after the and. To be quite honest with you, radicals maybe. I don't know. All right, so when we multiply like terms, we add exponents. If multiplication is addition, then division has to be subtraction. Seems legit. We have basically the distributive property. A times b to the x is a times a to the x times b to the x. And it's still the distributive property on this. We'd have a to the x over b to the x. Learn your properties. X to the negative n is 1 over x to the n. X to the p over r is the rth root of some x to the power, and the p can be on the inside, or it can be on all of it, on the outside. Anything to the 0th power is 1. It is. Half the student body thinks it's 0. Let's see here. Radicals, the nth root of a times b is the nth root of a times the nth root of b. And when you do division, the nth root of a over b is the nth root of a divided by the nth root of b. So, not too bad. It's basically a repeat of yesterday. All right, so here we have, how can you rewrite each expression using the properties of exponents? Well, first off, these are like terms. So, since I'm multiplying, I need to go ahead and add. All right, 5 6 plus a negative third. Now, a negative third is going to be negative 2/6. So this is going to give me 81 to the 3/6, which is 81 to the 1/2 power. Now, you may or may not believe me, but that's the square root. It is, swear it is. And ta-da, it's 9. Amazing, huh? It is. All right, example B. We're going to use what's called the distributive property of exponents here. We're going to distribute that 2/3 to every single thing. We'll have x to the 2/3. If we do 2/3 times 3, 2 times 3 is 6 over 3, that's a 2, so you have a y squared. Down low, 2 times 1 is 2, 3 times 2 is 6, 2 over 6 is a third. Now, what we have to do is we have to focus on these like terms here. So we have an x to the 2/3 sitting pretty over x to the 1/3, and division is subtraction of the exponential space. Now, 2/3 take away a third is a third. We'll have x to the 1/3 sitting pretty over, actually it's not sitting over anything, times y squared. Ta-da! I had ChatGPT create example C. I asked it for a hard problem. And to be quite honest with you, it doesn't look like it's a very hard problem. We're going to distribute that negative 2 to everything inside the parentheses. That's going to give me 2 to the negative second, x to the negative 2/3, y to the, let's think about this, that would be a positive 6 over 4, 3/2. And the denominator is still 2xy to the 1/5. All right, so little things here. If exponents are negative, think about this rule, x to the negative n is 1 over x to the n. I need to be moving these things, okay? Like 2 to the negative second is actually 1 over 4, because I skipped a step there, I'm sorry. It's a 1 over 2 squared, which is 1 over 4. So I'm going to put a 4 down low. I've already got a 2 there. Let's go ahead and wrap that 4 in a set of parentheses. I've got an x down low. See this guy right here? Also going down low. And let's see here. That's supposed to be a 1/5. I need to think about this y to the 3/2 over y to the 1/5. And again, subtraction, division is subtraction. So I'm going to take away a 5th. I need a common denominator. Common denominator between 2 and 5 is going to be 10. I'm going to have multiply this by 5, make it a 10. I'm going to have 15 over 10. Take away 2 over 10. I'm going to get y to the 13/10 in the numerator. But wait, there's more. Last I checked, 4 times 2 is 8. I have y to the 13/10 sitting pretty over an 8. And if I take this 1 and I add 2/3, I'm doing 3/3 plus 2/3, which is 5/3. Easy peasy lemon squeezy, and that is an exponent. It's hard to see that. Exponents are hard for some people to write in. They're smaller. They're a superscript is what we call them because they're up high and they're a script. They're small. Anywho, how can you extend the properties of exponents to derive the properties of radicals? In other words, how can you rewrite the cubic root of 16x to the fifth using the properties of exponents? Well, you can do that by simply doing x to the p over r. Now, you do have to be careful because this exponent's only on the x. What you have here is you have the cubic root of 16 times the cubic root of x to the fifth. You can't be the kid, and this is what happens a lot of times. Kids they'll say, okay, well, this is 16x to the 5/3. And it's wrong. It's 100% wrong. It is, because 16 had an exponent of 1. It was there the whole time. It was just understood. Boy, people don't understand the understood. All right, so anyways, how can we work with this thing? They want us to do what's called radical simplification. So when I see 16, what I see is I see a 8 times a 2, right? I can think about this as the cubic root of 8 times the cubic root of 2. And the cubic root of 8 can be rewritten or thought of as 2 cubed. But anyways, I can take the cubic root of 8. It's 2. I've still got this guy inside. So this reduces down to 2 cubic roots of 2. Now, when I think about x to the fifth, what I see is x cubed times x squared. And the reason I'm interested in the cube is because of that. The cubic root of x cubed has to be x. And I still have inside a cubic root of x squared. I'm going to go ahead and multiply these pieces together. That's 2x. And what's left inside their respective radicals is a 2x squared. This is a hard skill for some kids. It really, really is. I got to pause real quick because I think my copying job is done. So I'll be right back. 7. All right, so moving forward. So what you're hopefully catching on to, when we do radical simplification, we need to break the pieces down into what they really are. Like 81. What is 81? Well, 81, last I checked, was a 3 to the 4th. 8 to the 8th, 4 enters 8 nicely. We're just going to leave it alone. Maybe you remember that, maybe you don't. But or we can write it as 8 to the 4th times 8 to the 4th, because that's what she is. Right? We can also think about this 8 to the 8th using x to the p over r. We can think of it as a to the 8th, which is a squared. Look for little things like that. You know, those are reinforced things. B to the 5th is a b to the 4th times a b. Now, if you take the 4th root of 3 to the 4th, these guys kind of annihilate each other. You can think of that as 3 to the 4 over 4. So you'll get a 3. We already talked about this one. Each one of these a to the 4th generates an a, and an a times an a is an a squared. You've got your b to the 4 over 4, well, that's just a b. And what's left inside of this little radical is simply that last b. Ta-da! All right. What is the root of 15 times the root of, what is the 5th root of 8 times the 5th root of 16 in reduced radical form? Okay, so like I look at things and I see numbers. This is 2 to the 4th times the 5th root of 2 to the 3rd. When I multiply that together, what I would have is I'd have the 5th root of 2 to the 7th. All right, so let's think about that. That is the 5th root of 2 to the 5th times 2 squared. If you think about the 5th root of 2 to the 5th, you're doing 2 to the 5 over 5, which is 2. So you got 2 5th roots, and 2 squared, by golly gee wow, that's 4. All right. Ta-da! Like, it ain't that bad, kids. I don't know. It just depends on how much number sense you have. If you can barely add, it's probably pretty brutal. All right, what is the sum of square root of 20? And by the way, that is square root with the understood 2, minus the cubic root of 16, plus the cubic root of 250, minus the square root of 5. And it says, like radicals have the same index and the same radicand. Only like radicals can be combined with addition and subtraction. So your job here is to be able to reduce these radicals as far as you can and see if you can put them back together. So square root of 20, I can think of that as square root of 4 times square root of 5, which gives me 2 root 5. Now, already have this minus root 5. So if I put those two pieces together, what I have is I have a singular root of 5. All right, now I'm going to look at my cubic roots. I'm sure I can do something with these things. Let's say we have a minus cubic root of 16, which is 8 times the cubic root of 2. All right, well, the cubic root of 8 is 2, so minus 2 cubic roots of 2. And here we have the cubic root of 250. Now, I happen to know that the cubic root of 250 is the cubic root of 125 times the cubic root of 2. So that's going to become 5 cubic roots of 2 because the cubic root of 125 is 5. So we have plus 5 cubic roots of 2. And negative 2 cubic roots of 2 plus 5 cubic roots of 2 are 100% like, so I just focus on the numbers. Negative 2 plus 5 is 3, so plus 3 cubic roots of 2. It ain't rocket science. It ain't even science. It's math. All right, what do we got here? We got some square roots, and then we got some fourth roots, all right? So let's take a look at these square roots first off. Square root of 32x squared, okay? Remember, they understood 2. So think about x squared to the second power is x. Sorry, to the half power is x. Said that wrong. So this guy is going to have an x, and then I can think about 32. Square root of 32 is root 16 times root 2. And the root of 16 is 4. Still got a 2 inside the radical. So let's see if I can do something similar with the other one, which is the x root 50. That would be x times the square root of 25 times the square root of 2. So that's going to be 5x root 2. And there's a plus sign, so plus 5x square root of 2. Now 4x plus 5x, last I checked, was 9x. 9x root 2. All right, now let's take a look at our fourth roots. Okay, so 32 is going to be 2 to what power? The fifth. We have a negative y times the fourth root of 2 to the fifth. And 128 is 2 to the 7th. So plus the fourth root of 2 to the 7th, y to the 4th. All right, so I am going to focus on this. Okay, that is going to be 2 times 2 to the 4th. If I look at these two, I'm going to have a 2 out front. So minus 2y, fourth roots of 2. All right. If I look at this piece and this piece, I'm going to have plus a y. And bummer, I'm not going to actually be able to put anything together here. Because if I think about the fourth root of 2 to the 7th, I need to make sure that's right. It is. I would be taking the fourth root of 2 to the 4th, 2 cubed. And I can do that. I can take this piece. I can get a 2. But then I'm stuck with 2 cubed inside. And that's 8. So I really can't do much with this. As nice as it would have been if they would have been able to get put together, they cannot be. So my final answer is 9x root 2 minus 2y to the fourth root of 2 plus 2y fourth root of 8. And that is my final answer. All right, 2 to go. BRB. It's about to get fun, by the way. All right, so whether you do the distributive property of the box method is entirely up to you. X times x is x squared. And we're going to have plus x root 10. Think about multiplication kind of like glue. You just stick things together. Minus x roots of 10. And a square root times itself is simply the number inside, so minus 10. This is going to give us x squared minus 10 when everything's said and done. The second one is simply what we call the distributive properties. Root 6 times 5 is simply 5 roots of 6. Root 6 times root 3 is going to be root 18. Which, and wait, there's more. The root of 18 is 9 times 2. Think about that. Root 18 is root 9 times root 2. And root 9 is 3. So 3 square roots of 2. Always simplify. Always simplify. Now, I mentioned I didn't care if you did the box or whatever. You can do a box. There's nothing wrong with the box. If you like the box, do the box. We got x minus root 3, x plus root 5, x times x being x squared. 3 times 5 is 15, so minus root 15, x root 5, and then minus. I made a mistake, didn't I? This goes here. I got off, sorry. That was supposed to be take away x root 3. Now, you can't actually put any of these four pieces together. This thing is atrocious. You got x squared minus x root 3 plus x root 5, and then minus root 15. And you can't actually put any of those pieces together. So that one was kind of just, it got worse. Here's the fun part. How can you rewrite 2 plus root 5 without a radical in the denominator? So the question is, do you remember Milbrath's ugly root number theorem? It says that ugly numbers have conjugates. And it turns out that if you multiply two conjugates together, which we've done in this class before, that a lot of stuff cancels out. And that's what we're going to do. The conjugate of 2 plus root 5 is 2 minus root 5. Now this one's super easy. Up top, it's just the distributive property. 1 times anything is the anything. So we get 2 minus root 5. Down low, 2 times 2 is 4. 2 times negative root 5 is minus 2 root 5. Sorry, I'm losing my voice. Plus 2 root 5. And then minus 5. Gone, gone. 4 minus 5 is negative 1. Distribute the negative symbol. Negative 2 plus root 5 is the correct answer. Easy peasy lemon squeezy. All right, we're going to do the same thing. The conjugate of 2 minus the root of 3 is simply 2 plus root 3. And I guess up top, hey, let's do a box. I know that you guys, this is so time consuming for you because you have so much more stuff to do. 5 times 2 is 10. 2 times negative root 2 is minus 2 root 2. 5 times root 3 is 5 root 3. Root 3 times root 2 is root 6. Negative because you did a positive times a negative. So the numerator becomes 10 minus 2 roots of 2 plus 5 roots of 3, take away a root of 6. And if you want to do a box on the denominator, by all means, you do you. 2 minus a root of 3, 2 plus a root of 3, 2 times 2 is 4, 2 times negative root 3 is minus 2 root 3, 2 times root 3 is 2 root 3, root 3 times root 3 is 3, positive times negative is negative, and 4 minus 3, last I checked, was 1. So, hey, that's the answer right there, because if you divide by 1, you're just yourself. Now, what do you suppose the conjugate of 1 minus the root of x is? Because it's ugly. To form a conjugate, you change the sign on the ugly piece. It's 1 plus root x. And then we do multiplication here, kids. Negative 4x times 1 is negative 4x. Negative 4x times the square root of x is going to be negative 4x square root of x, which you might rewrite as a radical. You might. It's really up to you. It is. All right, down low, I'm going to do the FOIL method this time. 1 times 1 is 1. 1 times root of x is a positive root of x. Negative root x times 1 is a negative square root of x. And then a negative square root of x times a positive square root of x is a negative x. Gone, gone. Denominator is 1 minus x. Do not think you can do anything else with that because you sure cannot. Could you? No, there's nothing you can do that. Don't be thinking you can cancel out your x's because you cannot. Don't be that kid. If there's something you can do in math that's proper, I will show you. You are not smart enough to make up your own rules, kids, so don't do it.